Hello everyone. Uh, Two particles each with mass 0.85 kilograms are fastened to each other and to a rotation axis at O by two thin rods, each with lengths 5.6 centimeters and mass 1.2 kilograms. The combination rotates around the rotation axis with the angular speed 0.3 radians per second. Measured about O, what are the combinations A, rotational inertia, and B, kinetic energy? So here is the mechanical system, and we have four particles: one, two, three, and four. This rod and that rod. So we need to consider all these particles to find the total moment of inertia for this system. So we start Mi is the mass of ice particle, and Ri is the distance of that particle to rotation axis. So I becomes for particle 1 m d squared plus m 2d squared. For particle 2, the distance from particle 2 to rotation axis is 2d, plus moment of inertia for particle 3 and 4. However, instead of separating these two pieces, we can consider two pieces as one single rod and write I for rod about O. So we assume that we have a rod whose length is 2d and its mass is 2m. That's why we don't need to separate I for these two as two terms. Now the question is how we can find I for rod, this term. So we use parallel axis theorem for such purpose. So we say that if we have a rod like this, this point is center of mass, and this is the axis passes through center of mass, and we show it as O. The length of this rod is L, and the mass is m prime. And also we have another axis parallel to the axis through center of mass, at the left end of the rod. We consider this axis O prime, this axis O, and the rod rotates in this question about axis O. So based on parallel axis theorem, I about O, moment of inertia about axis O is moment of inertia about axis O prime plus the total mass times the distance between center of mass and axis O. We call it h squared. But what is O prime? O prime, by using the table of moment of inertia given in standard textbooks, is 1 over 12 m prime L squared plus m prime h prime squared. What is m prime? In this real question, m prime is 2m. What is L? L is 2d. Plus 2m. What is h? H is equal to d. So we can find IO as 8 over 12 m d squared plus, sorry, here is d squared plus 2m d squared, or 8 plus 24 divided by 12 m d squared. And if we simplify the result, we will get 8 over 3 m d squared. This is moment of inertia for the rod about axis O. So we need to use this result here. So we have 4m d squared and 1m d squared. We get 5m d squared plus 8 over 3 m d squared, and this is 5m plus 8 over 3 . Next step is replacing the quantities. So 5 times m m is 0.85 plus 8 over 3 times m is 1.2 times d. So d is 0.056 meters squared. So we get 4.25 plus 3.2 for this term times 0.056 squared. And this is 7.45 times 0.056 squared. At the end, it becomes 0.023 kilograms meter squared. This is the result for part A, moment of inertia. For part B, kinetic energy, the only kinetic energy for this system is rotational. And K for kinetic energy, which is only pure rotation kinetic energy, is 1 over 2 I omega squared. And I is 0.023 times omega squared, which is this 0.3 and then after calculating this part we will get 1.05 times 10 minus 3 joules, and if we round it we get 1.1 times 10 minus 3 joules, or 1.1 millijoules, which is the kinetic energy for this mechanical system consisting of 4 particles. Thank you for watching.